Okay, this is my Windhurst machine that I made, the very first one I made several years back, and I've experimented with many different discs, but what I've done here is this is pretty much the record as far as the spark length to disc diameter ratio that I've ever achieved. And surprisingly, it doesn't come from fancy metal balls turned on a lathe or anything of that nature. The great surprise is that it comes from something that's very crude and simple. What the deal is here, the anode has to be a smaller sphere. Well, in this case it's a cabinet knob, and the cathode has to be a large sphere. And the cathode doesn't even have to be a perfectly smooth surface. This is just a styrofoam ball wrapped with aluminum tape and aluminum foil. And as you can see, the surface is pretty rugged. Now, what I'm going to show here, the actual spark length is, I believe, 6 inches when I measured it just a second ago. Let me see. Yeah, you've got a spark length of 6 inches right here. And I hope you can see it with the camera. I'm trying to keep from getting shocked because I know these things are still charged. But it's 6 inches. I got it around 6 inches. But the funny thing is, the disc is only has a radius of 6 inches. You know, 12 inches essentially in diameter. And that's amazing because that's quite an impressive ratio for spark length to disc diameter. And usually the limitation on the maximum amount of voltage is determined by the sum of the spaces between the sectors from here to here, and from this charge collector to the corresponding neutralizer brush, this being a neutralizer brush and there being another one just like it on the other side. The capacitors are amazing. I took peanuts, styrofoam peanuts, and I put aluminum foil around the inside and put the styrofoam peanuts in there to press the aluminum foil against the inside, and then on the outside I wrapped aluminum foil and sealed it with tape. So, but as you can see, the little cup hooks up here, which have little wooden beads I got from the Walmart hobby section on the end of it to insulate the sharp edge. Okay, these cup hooks are coupled to the foil that's around the inside surface of this jar here through just a strip of aluminum foil, and as you can see, it's all crinkled and uneven, but leakage does not occur on the inside of the jar. You can have real rugged surfaces in there, and coronal leakage, it's basically sealed. It's not going to leak and cause like it would if you had a sharp surface on the outside, and therefore you don't lose tens of thousands of volts just by having jagged and uneven surfaces on the inside of the jar. If you do, it's certainly negligible. Given the difficulties that would be required to make something where everything is perfectly smooth inside and out, given those difficulties, it's quite an easy solution and quite effective. And for how simple it is, it's certainly worth not worrying about having everything perfectly smooth on the inside, as you're about to see. Here we go. There we go. I don't know if you can see that, but that's quite an impressive long spark. I know we're at about 6 inches. Let's see if this will work. Struggling. Oh, there we go. So anyway, but that's quite impressive, just for this small machine to get sparks that long. And actually, that's almost 6.5 inches right there. But you've got essentially 12-inch disc right here, and let me see. Yeah, you've literally got 12-inch disc right here is all this is. And for that disc diameter, that's an impressively long spark. The secret behind it is, and a large part, is having a small sphere. And notice that this right here, that cabinet knob has a sharp, abrupt edge right there, and it's just kind of JB welded onto the end of this aluminum rod right here, and everything is just kind of held together using these wooden beads. The wooden beads are slid on the end of the stems here, the output stems, and then holes are drilled at a 90-degree angle, and the rods are just pretty much dropped in there. This one here is kind of tough to pull out because it's real snug, and I'm trying to keep from getting shocked. These things stay charged, okay, see? So they just pull out. But as long as you have the small sphere for the anode And the large sphere for the cathode, you can get impressively large sparks, and if you have an extremely large cathode, then see how uneven this is? You can see part of the styrofoam sticking there where the foil just kind of comes to an end right there and just doesn't wrap all the way around. You can have real jagged stuff and get just remarkably long sparks. So I just wanted to show that. If you read a lot of stuff, it's probably going to tell you that everything has to be perfectly smooth and all this good stuff. But not everything has to be smooth. It's in knowing what has to be perfectly smooth and what can't be jagged and sharp. It's knowing what. It's not that everything has to be perfect and milled in some high-tech machine shop. So you can get away with some really scratchy stuff if you just learn what works and what doesn't. The thing about corona leakage to air, which can take a machine like this and just put it in the mud totally, where you can't get sparks hardly an inch long. The one thing that'll kill your voltage is corona leakage to the air, charge leakage, because the current output from these machines is so low. And what really seems to be most effective at stopping the corona leakage is using something that's not a perfect insulator. So as you can see, I've used wood on all the ends here and in all the joints, because wood really does a good job of keeping the charge from leaking out into the air. And these little cup hooks used for the Leyden jars have just got, like I said, little wooden beads I got from like the hobby department. And you can get them just anywhere, and it's just slid over the end of the cup hook. I'm being careful here, see? Now if I didn't have this over it, that would be leaking a lot of charge off the edge of that metal there into the air. But that's a big secret right there in getting long sparks, is insulating. I keep getting shocked here from the table, believe it or not. But insulating everything from corona leakage by using something that's not a perfect conductor, you know, like wood or something. And to mention that these things will shock you. They'll knock you for a loop. So you want to be very careful, because long after you're done playing with a machine, these capacitors will stay charged, just like batteries. So it's something to always be mindful of. But I thought I would share it. I know it's a little disjointed and a little disorganized, but I'm kind of doing this on the fly. I hope y'all enjoy.